Just getting set up here. And all right, action. Okay. Hi, my name is Ryan. I'm joined by my teammate Aditya, and together we're going to be talking about using machine learning to mitigate employee turnover. For our agenda today, we'll start by introducing the problem and a light overview of the solution. Then we'll talk about our data set, move on to methodology, our model results, and conclude with some recommendations. And with that, I'll pass it on to Aditya.
Hey, thanks, Ryan. So here's the problem definition. We all know that workforce retention is a serious problem because there are a lot of costs involved with respect to retraining a new employee. And when an employee leaves the organization, the employer suffers a lot. There are disruptions in operations. The HR department has to go through uh, one full round of hiring process to get a new employee. And also there is a moral impact on the rest of the employees of the organization. So we try to have an effective solution to this problem definition. So the solution consists of a classification model for employee attrition. We identify the closest match employees who have not left the company, and we also generate a personalized suggestions to retain the employees who are probably going to leave. So here is an example of a suggestion that is that the employee satisfaction level is low and the employee is lesser involved than others. So we encourage that the employee participates more actively in work tasks and initiatives. So here's the dataset overview. The dataset is synthesized by IBM engineers. It consists of 35 columns, including job quality factors and a Boolean target variable attrition. The data is more or less cleaned because it is synthesized, and we did not use a lot of cleaning processes. The data is, however, imbalanced. There are only about one of seven observations who left the company. So we use SMORE to sample the employees who leave. Other than that, we also reduced outliers and normalized the data for modeling. I'll hand it over to Ryan.
Yeah, thank you, Aditya. So determining employee turnover is fundamentally a classification problem when we're working with two labeled outcomes. Um, as he mentioned earlier, employee retention is a Boolean variable. Either we retain an employee or the employee leaves the organization. Because we aren't working with longitudinal data, we're strictly concerned with the factors that influence employees to leave, rather than the point in time when an employee decides whether to leave or stay at the company. We tried out 7 different models, including simple classification models like stochastic gradient descent and logistic regression. We also attempted the models that work with Bayesian inference, such as Gaussian naive Bayes classification. And we finished with a series of ensemble methods that experimented with gradient boosting. And those include random forest classifiers, rule fit, and AdaBoost. We attempted dimensional layer reduction and hyperparameter tuning, PCA for random forest and logistic regression. As you might know, PCA for random forest traditionally doesn't work very well. A random forest model already has some dimensionality reduction built in. And that was something that we were able to work with in greater detail through hyperparameter tuning, where we were able to set a maximum depth and maximum number of rules for rule fit, which is also fundamentally rooted in a gradient boosted random forest. Our tuned rule fit had the best accuracy and precision. And second to rule fit was AdaBoost, which had the recall. But really, the model that struck the right sweet spot was our random forest classifier over here, which had the second best accuracy and precision, and a rather significant recall also. One of the benefits to having a random forest classifier is interpretability, because we're able to look at decision trees. You can see that here in greater detail. The tuned random forest classifier has rather high scores for accuracy and precision. So when we talk about the features selected for random forests at a very broad level, stock option level plays a really big role, followed by monthly income and job satisfaction. Um, and when we use a rule fit model to demonstrate the most important interaction effects between our features, you'll see that stock option level does matter quite a lot, but it also matters in the context of the other features um, that are also included among those observations. So senior employees who have stock options, new managers, and low job satisfaction are likelier to leave. Uh, Employees who don't have stock options, but have an education in the medical field or life sciences, have low relationship satisfaction and low job satisfaction, probably have better exit options and are likelier to leave also. Unfortunately, we don't have the coefficients for the rule fit model because we're working with an older package. But we can get greater resolution into how these features interact with each other by looking at a random forest directly. So we will see that briefly in this notebook, where we've actually visualized a random forest. So let's say that you have a junior employee who spent less than 4.5 years at the company. Because all these features are evaluated sequentially, if they do in fact have less than 4.5 years of the company, if they have good environment satisfaction, hot like monthly income that's rather lower, no stock options, male, research scientists, travel frequently, or sorry, don't not a research scientist, doesn't travel frequently. All these factors together actually surprisingly result in employee retention. But if you go towards less than 4.5 years, environment satisfaction, low total number of working years, was not trained last year, all that contributes to employee attrition. And based on our optimal model, we also came with a probability of employee attrition, and our model has the ability to predict whether an employee can leave based on inputted factors. And that's something that Aditya is going to talk about in more detail.
Sure. So coming to the intervention part of this problem statement, our model not only classifies whether an employee is going to quit or not, but also it aims at identifying the underlying reasons why the employee might be quitting. We do this by comparing the features of the employee who's going to quit to the employees who did not quit. We'll try to find the closest match between these employees. So we do this by using k-means clustering. On the employee who's going to quit, we find the closest match for y equal to 0, which means the employees which are not going to quit. We find three of these employees and average out the values of these three employees so that we have a more robust solution. And based on these values, we compare the values from the employees going to quit and the employees who did not quit, and then we suggest some modifications like you see on bottom right of the screen. Um, an example of suggestions is shown on the next slide. So yeah, this is an example of a suggestion where it says that the employee satisfaction level is lower than average, the hourly rate is lower, the involvement is lower than average, and thus the suggestion would be to encourage the employee to participate more actively in work, tasks, and initiatives, and so on.
So for our final recommendations, based on some broad takeaways from our model performances, if stock options seem to influence employee retention a lot, look into whether stock options are reserved for exclusively more senior employees, whether the size of the stock option matters, and therefore whether it's possible to distribute the stock options among more employees. Another problem is that junior directors seem likelier to leave because this is a rather thorny problem that exists across all workforce development, um, like all workforce sector or all sectors. It's better to create training materials to prepare for the inevitable employee turnover so that you can lessen the blow. Um, Another problem is that the combination of relationship success, job satisfaction, and whether employee has an education in life sciences um, results in employee turnover. So it would be prudent to conduct a survey to assess what values align with those who have backgrounds in the life sciences and adjust work culture parameters from there, especially because relationship success, job satisfaction, these can be really sensitive topics to navigate. And it's best to let the employees themselves lead the conversation there. And with that in mind, those are solutions for IBM, and we hope that they take our insights for the human resources team into account for the next quarter. Thank you. All right. Stop recording.